Okay, so section 4, part 2. So you guys practiced these last time, these first 4 last time. So the first one is definitely a factoring one. So we go ahead and we factor the numerator and the denominator. So did you guys all do that? And it factors into x plus 1 times x plus 5 all over x plus 1 times x minus 4. So when you did, the x plus 1 should have canceled. That removes the part that made it undefined. Okay, so now you're able to plug in -1 without getting like 0 over 0. So when you plug in -1, you get -1 plus 5 over -1 minus 4. So you should have an answer of 4 over -5, which is -4/5. Did you guys all get -4/5 for that first one? Awesome. Okay, so the next one's a little bit different. So yes, the bottom does factor. It factors into x minus 4 and x plus 2. So it's definitely looking like there's an issue there, right? It does not exist or something like that. But we don't know. Maybe it goes up to infinity, like both go up to infinity or both go down to negative infinity. There's an asymptote there. So this is one where you kind of think about what the graph looks like. So 4 and -2 are vertical asymptotes. We have a horizontal asymptote at 0. Do you guys remember the trick for horizontal asymptotes? We were just talking about that. So at 0, we have a horizontal asymptote. And then we could figure out where everything lies by doing like a quick t-table. You guys did this process in Algebra 2. Nobody liked it in Algebra 2. Hopefully you did it again in pre-calc. Did you guys do this again in pre-calc? And maybe you understand it a little bit better. But we'll go ahead and let's look at our graph. So go to graph it for y1. Did you guys all do that last time? So under my y equals, I'm going to put 3 minus x divided by x squared minus 2x minus 8. And I hit graph. Okay, and my graph is going to show, sometimes it shows asymptotes, which makes it a little hard to read. Okay, so it looks like here we're above the curve. And like I said, if you had done a t-table like in your head and you plugged in like -3, you'd get a positive number. All right, hang on. I guess I can't plug in numbers, so let me go back. So at -3, I get a positive 0.857. So we're above the axis. And then you can kind of play around with the other ones. So if you look at the graph for this, it looks like we're below the axis, but it's kind of hard to tell what's happening over here. I think it's one of those ones that looks kind of like a cubic function and goes back up, but I can't tell from my graph. Do you guys see how my graph looks a little funky? Can you guys see the graph? It's so hard to see the green screen. So in that case, I would maybe plug in like a positive number to see what's happening. So plug in something close to the asymptote, like maybe 3.9 or something. So if I go to my table and I want to put in a certain number, you can make it so it's ask. You guys should already have that. Mine resets every time. So I get 1.5. So I see it crosses that axis. And that's all I really wanted to know. I just wanted to know if it crossed or not. Oops. And then it looks like on the other side we're below. Okay, so it's like that. So as we talk about the limit as x goes to 4, just in general, not from the right or left, we see that the right-hand side goes to the negative infinity, and the left-hand side goes to positive infinity. So what are we able to write for that one? Does not exist. And I think many of you guys figured that out when I was going around and checking last time. I think you guys all got that does not exist. Okay. So the next one. So this is one where you have to rationalize. So you're going to multiply through by the square root of x plus 4 plus 2 all over the square root of x plus 4 plus 2. And when we did this a couple days ago, we left it factored on the bottom, and we were hoping that that x part would go away. That's what's making it undefined, right? The fact that we have an x on the denominator and we can't plug in 0 through x. So when we FOIL out the top, you should get x plus 4, and then our outer and inner terms cancel each other out. They're gone. And then we have minus 4. So do you guys see all the magic that's happening here? 4 minus 4 goes away. X and x go away, so we're left with 1 on top. You with me? So now you can plug in 0. So you get 1 over 2 plus 2, which is 1/4. So that's our answer. All right, did you guys all get 1/4? All right, and then the last one, you should get common denominators. So you should multiply by t over t, 2 over 2. So we get limit as t goes to -2, and we have t plus 2. I feel like this is like a song. I don't know. T for 2. Is that the song? I don't know. So t plus 2 divided by 2t, and then all divided by 2 plus t. So what we're thinking of is we have our t plus 2 over 2t, and we're dividing by the 2 plus t, which is the same as multiplying by 1 over 2 plus t. Okay, did you guys all get to that step? So what happens is the 2 plus t and the t plus 2 cancel, and you're left with 1 over 2t. So did you guys get -1/4 for that one? All right, good. So you guys feeling pretty good with these limits? Hopefully. They're strange at first. Now I do want to show you a quick shortcut for that. So the more advanced, like the better you get at math, sometimes you look for shortcuts. And if you have a complex fraction, there's actually a trick. You could multiply by whatever your common denominator would be for each one. Have you guys seen this trick before? So I can multiply by 2t and 2t. And that 2t goes into both of these here. You guys see? So what would I get on the top then? Yeah, I'd get the t plus 2. And then over here I'd have that 2t times 2 plus t. And then I don't have to worry about the dividing and flipping and all of that. Okay. So you might have seen that previously, like if you had like 3/4 plus 1/2 over 5 minus 1/8. Have you seen like things like that? Look at the denominators of all of the fractions within the fraction. So we have denominators of 4, 2, and 8. So what would I multiply by on the top and bottom? 8. So when we do that, we end up getting 3/4 times 8, which is 6, plus 4, all over 40 minus 1. So it gets there a little bit faster. So we have 10 over 39 would be our answer. Does that make sense? So if you want to use that trick, you can. No big deal. All right. We're good. Okay, so the next one is one of those piecewise functions. We actually did this one just on the board, I believe, didn't we? Didn't we just do this exact one? So basically, if you talk about the limit as you go from the right-hand side, you would use values that are greater than 3. So you would plug in 3 into that function. So 3 minus 1 is what it would be. But the limit from the left-hand side of our function would be that 2x minus 3. So you'd have 2 times 3 minus 3, which is 3. So since they don't go to the same thing, we say the limit as x goes to 3 of our function does not exist. Okay, so it says sometimes it's easiest to calculate limits by first finding the left hand and then finding the right hand limit. So remember, the limit only exists if the limit from the right and left are equal to each other, and they both equal that limit, that L. So you'll probably be using that quite a bit on the AP Calc exam. So using the fact that the right and left go to the same thing. Okay, so number 1, so it says prove that the limit as x goes to 0 of the absolute value of x equals 0. Okay, you could do this lots of different ways. It's really a piecewise function. But you could draw the sketch. This line is y equals x. This line is y equals negative x. Right? Both of those, when you plug in 0, go to 0, right? I'm not going to spend a lot of time like going through the proof of that. We're fine. We can do that. Okay, so number 2. So it says the limit as f of x equals the square root of x minus 3 if x is greater than 3, and the limit as of f of x, or sorry, f of x is equal to 6 minus 2x if x is less than 3. So determine whether the limit exists. So do they go to the same number when you plug in 3? Yeah, they go to the same number. Do we see that? So what you would need to write is you would need to say the limit as x goes to 3 from the right uses this function. So we're going to have the square root of 3 minus 3, which is 0. And the limit as x goes to 3 from the left is 6 minus 2 times 3, which is also equal to 0. So yes, the limit as x goes to 3 of f of x equals 0. What is f of 3 though? Like if I just asked for f of 3, right? Why does it not exist? Right, there's no like equal. So if I had greater than or equal to, then I would just use that top function and be like, oh, it's 0, right? Do you guys understand? There's actually a hole on this piecewise function because there's nothing existing at greater than or equal to 3, right? There's no place where it's equal to 3. So there's no point that's filled in at 3. So that one's undefined. It doesn't have a point with it. All right, so 2 special trig limits. So these ones you will need to know for the AP exam. They pop up quite a bit. There's actually a trick called L'Hopital's rule. And L'Hopital's rule used to not be on the AP exam, but it is now. It will help you memorize these later. But you should probably memorize them now and know them. So the limit as x goes to 0 of sine of x over x is equal to 1. And the limit as x goes to 0 of 1 minus cosine of x over x is equal to 0. Okay, and you could look at what those graphs look like if you want to put it into Desmos or something, and I think you'll see why they go to each thing. Or you can put it in your calculator. All right, so it says the limit as x goes to 0 of tangent of x over x. So this doesn't look like either one. Which one do you think we're using, the first one or the second one? Probably the first one, right? So what am I going to do, Jacob? What do you think?
Change tan of x.
Yeah. Yeah, let's try changing it around, right? Let's make it sine over cosine. So we're going to make it the limit as x goes to 0, and we're going to do sine of x over cosine of x. And we're dividing by x, right? So we have the limit as x goes to 0, and we have our sine of x divided by its cosine, but we're multiplying by 1 over sine, so we're going to get x cosine of x. And then we just kind of think about all those limit laws. Do you guys remember how I gave you those like 11 very, very boring limit laws? We can pull things apart. So we can pull apart products and take the limit of both. So I'm going to do the limit as x goes to 0, and I'm going to say sine of x divided by x times the limit as x goes to 0 of 1 over cosine of x. So I just broke apart the two things. Did you guys all see where I did that? Okay. So basically, if I had multiplied these two together, I get this. So I just pulled them apart. All right, so this first one is one that you should know. So that goes to 1. And the second one, I think we can find. So let's see, am I able to plug in 0? What is cosine of 0? Yeah, cosine of 0. Not 1 and negative 1, just 1, right? Makes sense? So we're going to have times 1 over 1, which is still just 1. So our answer is 1. So you got to kind of know how to break things apart and see those missing pieces that we need. All right, so this one's really weird. Let me show you why this is what it is. It's going to end up being 9. So I'm going to show you why it ends up being 9. You're not going to like it. And then I'm going to show you a shortcut. And you'll be like, oh, thanks, Mrs. Cox. Okay, so are we ready for the part you aren't going to like? Okay, so it says use substitution to compute the limit as x goes to 0. So what we're going to do is we have something weird here. We have limit of 9x, or sorry, sine of 9x. Okay, that's weird, right? That's like one of those multiple angle ones. We want it to just be sine of x. And if you look at our formula up here, see how it's just sine of x? That's what we want. So we're going to do w substitution. So we're going to let w equal 9x. Okay, so we're going to start replacing, and we're going to be like, okay, well, I definitely have the limit of something. So if I have x going to 0, well, that's really w over 9. So I'm going to write it as w over 9. Oops, w over 9 goes to 0. And I have the sine of w over, what do we think? So what's x? W over 9. So I replaced everything with w's. So if I'm dividing by w over 9, remember that means I'm multiplying by 9 over w. So I'm going to do that on the next step. So I'm going to say the limit as w over 9 goes to 0. So I have the sine of w over the 9 goes on the top with the sine of w, and the w goes on the bottom because I'm multiplying by 9 over w. Everybody's still good? Okay, this is weird. I don't like w over 9 goes to 0. If w divided by 9 is going to 0, what is w going to? Do you guys see what I'm saying? w is really going to 0. I don't have to do the w divided by 9. If some number is getting closer to 0, right, that number divided by 9 is also getting closer to 0. So I'm going to rewrite it. So we have the limit as w goes to 0. We have that extra 9. So we can do the 9 like on this side. We can put it out front, right? It doesn't matter where we put it. It's up to you. You can leave it in the problem if you want. If you want to put the 9 right there. But the sine of w over w and the limit as w goes to 0, what did that all go to? 1. That was the thing I said to memorize, right? So it's 1 times 9, so it ends up being 9. Okay, we don't want to do that every single time. All right, so there has to be some kind of trick. So I could do the same thing for this. I could do my w is equal to 5 over x, and so on. This one goes to 6/5. What do you think this one goes to? 7/4. Isn't that magic? All right, what about this next one? Ah, tricked you. So in the problem, this is why you have to memorize these. So flashcards. What's the limit as x goes to? Yeah, it's going to 0. How did I trick you on this next one? It's going to infinity. So the AP test does that too. They trick you. So all of these were the limit as x goes to 0. So you can basically look at it, and whatever numbers are here, you just divide them out. You're like, oh, it's 7/4, right? And it doesn't matter if the sign is on top or if it's on the bottom. It doesn't matter. So like really the limit as x goes to 0 of x divided by sine of x, like if I flip it around, that also goes to 1, right? So that's why this next one, or the number 3 went to 6 over 5. Okay, but the issue with this last one is that we have the limit as x goes to infinity. This is not x goes to 0, so be careful. So anybody have any idea on what theorem we can use to prove this one? A theorem. Imagine it being said in a funny Kentucky accent. The squeeze theorem, that's right. The squeeze theorem, my favorite. All right, so we're going to squeeze it between two things. So sine is always between what two numbers? 1 and -1, right? So we're going to think, okay, sine of x is between 1 and -1. Okay, we want to be able to divide by x. Okay, but that's a little tricky because sometimes x is negative. If x is negative, it flips all of our signs. How do I know I'm not going to plug in values that are negative? Because I'm going to infinity, right? So x goes to infinity. So let x be a large positive number. Okay. So then we can squeeze it. So we're going to divide by x, divide by x, and divide by x. And then we say, well, the limit as x goes to infinity of -1 over x equals something. And the limit as x goes to infinity of 1 over x equals something. As you plug in a really, really huge number in for x and -x, or into 1 over x and -1 over x, I guess we should say, what are we going to? Yeah, it goes to 0. Do you guys see that? It's like 1 over a huge number, -1 over a huge number. It gets closer and closer to 0. So this goes to 0 by the squeeze theorem. Now, do you have to write that out every single time and like on the AP test and so on? No. Okay, you just need to know this concept of as you go towards infinity, what's bigger? You know that sine is limited, right? Sine is at most 1. But as I plug in x goes to infinity, the bottom gets huge, right? So you have a small number divided by a really huge number, so it's going to 0. That's the concept I want you guys to understand. Okay, so let's stop there.